Some examples on differential equations which are solvable for y. Okay, so solve this differential equation. So first we see very carefully. This is a differential equation of first order and higher degree in form of x, y and p, means x, y and p equal to 0. Okay, so first we see degree of y. So in whole differential equation, degree of y is 1. It means, and degree of x is 4. So it means this is solvable for y. So first we will write y is left hand side and other part right hand side. So y is equal to minus px plus x4 p square. Okay, this is the first step. Now differentiating with respect to x, we get dy by dx equal to, here product of two function, minus p, differentiation of p is dp by dx and x as it is, plus here minus p, differentiation of x is 1, plus product of two function, 4x cube p square as it is, and plus x4, here 2p dp by dx. This is the next step. Now putting dy by dx is equal to p. Okay, so this is p. So p is equal to minus x dp by dx minus p plus 4p square x cube plus 2p x4 dp by dx. Okay, here p and p, 2p, and this is minus 4p square x cube, and remaining terms are is equal to minus x dp by dx plus 2px4 dp by dx. Here 2p is common, so 2p, 1 minus 2p x cube is equal to, here x dp by dx is common, so minus 1 plus 2p x cube. Okay, this is same thing, only minus sign change. So by taking common minus 1 here, so minus x dp by dx, so here 1 minus 2p x cube. So on dividing by 1 minus 2p x cube, so we get 2p is equal to minus x dp by dx. This is variables are separable. It means dp by p is equal to minus 2 dp by p is equal to minus 2 dx by x. Okay, means dp by p dx by x. Okay, so this is variables are separable on integrating. So we get log p is equal to minus 2 log x plus log c, where c is constant of integration. Okay, either this, so our aim is to calculate value of p. So p is equal to c by x square, because by the property of log. Now substituting the value of p in given differential equation, means this is a given differential equation 1. Okay, so now substituting the value of p. Now substituting the value of p in given differential equation. So solution is y is equal to minus p means c upon x square. So c upon x square into x plus x4 p square means c square upon x4. So this is equal to x4 cancel. This is y is equal to minus c upon x plus c square. So this is the answer. Okay, so this is very easy to solve, means differential equations solvable for y. So what is the method? First we see very carefully given differential equation and degree of y is 1. So first we write y is equal to remaining thing in right hand side and then differentiating with respect to x. So this is differentiation. Then putting dy by dx is equal to p. Okay. Then our aim is to calculate the value of p. So by solving these things, we get value of p, and then by putting value of p in given differential equation, so this is the solution. Okay. One thing is that if we can't find the value of p, then last relation and given question is the combined solution. Okay. Differential equations solvable for x. Okay. The same method as we have solvable for y, means this is a differential equation y x y p is equal to 0. So first we see very carefully. If differential equation solvable for x, then degree of x is 1 in given differential equation. Okay, means degree of x is 1. And then we put x is equal to all the things in right hand side, means this is function of y and p. This is the next step. Next step is differentiating with respect to y. Okay. Then dxy dy is equal to d over dy f of yp. Okay. Next step is putting dx upon dy is equal to 1 upon p. Since dy by dx is equal to p, so dx upon dy is equal to 1 upon p. So this is d dy f of yp. Our aim is to calculate by solving value of p. Okay, value of p. And then putting this value in given differential equation, which is solution. Okay, putting value of p in given equation, which is required solution. One remark: if this is not possible to calculate the value of p, then last relation and given equation are solution of given equation. Okay, means last relation for p and given equation is the solution. So this is an example solvable for x. Okay, so first we see very carefully given differential equation. So degree of y is maximum 2. Okay, so this is not solvable for y. Here degree of x is 1. So this is solvable for x. So first we put x in left hand side and other things in right hand side. Okay, so this can be written as 2px is equal to y minus y square p cube, and dividing by 2p. So x is equal to y upon 2p minus y square upon 2p square by dividing 2p. So we get x Here 2p. Okay. Next step is differentiating with respect to y. Differentiating with respect to y on both the sides. So we get dx upon dy is equal to here 1 by 2 numerator and denominator. So are product of two function as you would like. So differentiation of y is 1. So 1 upon p minus y upon p square dp by dy. Okay. Here minus 1 by 2. Here also differentiation of 2y p square plus y square into 2p dp upon dy. Okay. Now dx upon dy is equal to 1 upon p. So this is 1 upon p is equal to 1 upon 2p minus y upon 2p square dp upon dy minus 2 to cancel. So yp square minus y square p dp by dy. We will collect same powers of term, means term containing dp by dy one side and remaining term other sides. So this is 1 by p minus 1 by 2p, okay, plus yp square, and in right hand side here dp by dy is common, minus dp by dy common, y square p and plus y upon p 2p square. Okay, dp upon dy is common, so here y square p and here y upon 2p square. This is minus 1 by p minus 1 by 2p, so 1 upon p, so 1 upon p plus yp square is equal to y is also common, so minus y is common, so y upon 1 upon 2p square plus yp and dp by dy. Okay, now here 1 plus yp cube upon p is equal to minus y 1 plus yp cube here 1 minus 1 by 2, so this is 1 by 2. Okay, so 1 plus 2 yp cube upon 2p. Okay, here 1 plus 2 yp cube upon 2p square dp by dy. Here 1 plus 2 yp cube, 1 plus 2 yp cancel, 2 cancel, p and p cancel. Okay, 1 is equal to minus y upon p dp by dy. So this is variables are separable. Okay, means dy upon y is equal to dp upon p. So dp upon p is equal to minus dy upon y. On integrating, so we get log p is equal to minus log y plus log c. By property of logarithmic, this is log c upon y, so p is equal to c upon y. P is equal to c upon y, or c y to the power minus 1. Okay, this is the value of p. Now putting the value of p in given equation, so solution is 2px, p means c upon y x, is equal to y minus y square p cube, means c cube upon y cube. Okay, so 2cx upon y is equal to y minus y square, y cube cancel, so c cube upon y. So this is the solution, this is the answer. One thing is that if given equation is first degree in x and first degree in y, so we can solve either solvable for x or solvable for y. Okay, so this is the important thing. Clairaut's equation. A great mathematician, Clairaut solved the differential equation of first order and higher degree. Okay, as we know, differential equations of first order and higher degree can be solved as three type of classifications, means solvable for x, solvable for y, and solvable for p. So a differential equation which are solvable for y is known as Clairaut's equation, but all equations are not Clairaut's equation. So a differential equation of the form y is equal to px plus f of p, okay, is called Clairaut equation. Okay, so this is the important that in left hand side y and px plus function of p, this is function of p. Okay, so this is known as Clairaut equation. So how we solve? So by putting p is equal to c, by putting p is equal to c, so solution is y is equal to cx plus function of c. So this is the solution. How we solve Clairaut equation? Okay, so this is very easy. If y is equal to px plus fp, so since this is differential equation solvable for y, so first we differentiate with respect to x. So dy by dx is equal to product of two function. So p plus x dp by dx plus f dash p dp by dx. Next step is by putting dy by dx is equal to p. So p is equal to p plus dp by dx is common, x plus f dash p. Okay, p cancel, so dp by dx and 0. Since this thing is not equal to 0, means dp by dx is equal to 0. So on integrating means p is equal to c. So by putting p is equal to c in given differential equation, y is equal to px plus fp, so this is the solution. Means y is equal to cx plus f of c. So this is important that what is Clairaut equation? The equation of the form y is equal to px plus fp is called Clairaut equation.